Welcome back everyone to another video in our Fundamentals of Structural Engineering course. In this video, we are going to talk about inference line for beams. First of all, we want to understand what is the meaning of inference line. If we have this beam here, AB, a simply supported beam, and we assumed having a moving load here. This load is going to be moving between these two supports between A and B. This load in real life could be a crane, could be a vehicle load, could be any other load that doesn't have a specific point of application. So we want to understand what will be the reaction for this support A and for this support B. At each location this load will be moving. In this case we have only one load, so it makes sense that if this load is applied here at this point, this support is going to have the full reaction, while this support is going to have zero reaction. And as it keeps going in this direction, the load will start to be distributed between the support A and the support B. So if the moving load is exactly in the middle, this means that A will have 50% of the load and B will have 50% of the load. And as it keeps moving in this direction, the support A reaction will keep getting lower and B will keep getting higher till the load is directly on top of this support. Then the support B will have the full reaction and support A will have zero. So if we have here this beam and we want to draw the inference line for reaction at support A, it is going to look like this. Here we have the full reaction, which is 1, and here we have 0. This means that at any point, if we assume that we have load here, this will be the value of the reaction at this support. So in the middle, you will see that it will be 50%, which is the reaction here. And for the reaction at support B, it will be the inverse. It will be here will be the value 1 and here will be the value 0. There is very important thing you can see at the inference line, that if we are drawing the inference line for the reactions, all the reactions, you will see that the summation at any point will have to equal 1. So if we took the summation at this point, you will see here 0 and here 1, the summation is 1. Here it is 1 and 0, again the summation is 1. In the middle it is 50 and 50, 50% and 50%. It will always be 1 because this is because it makes sense. If the load at any point, this means that the overall load must be distributed between the support A and B. There is a very useful trick. It can make it for you easier to draw the inference line for the reactions. I'm going to show it to you now. Here we have this moving load and we have these two supports A and B, and we want to draw the inference line like we agreed. When you want to draw the inference line for the reaction A, what you are going to do is that you are going to remove this support and you will assume that you have a vertical force here. And based on this vertical force, I want you to draw the deformed shape based on this load. So if we have a vertical load here going upward and we have a support here, this will be the shape of the deformed shape. It makes sense. It will start moving up from here and here it will remain connected to the support. You will see that it is the same shape of the inference line, and always the value at the support equals 1. And this is what we have already calculated here. The same we will do here. We will remove the support and we will assume a vertical force here and we will draw what will be the deformed shape. You will see that it is the same shape of the actual inference line. So let's have another example on this. Here you have this beam, simply supported beam with cantilever with this dimension, and you want to draw the inference line for the reaction at support A and at support B. We will start, like we said, we will remove the support at A and we will assume a vertical force going upward here. So the deformed shape is very simple. It will go upward in this direction. And we said that the value is always 1 at the support. So here the value is 1, and based on this dimension and this dimension we will calculate the value here. I'm going to show it to you now. And at the reaction B, we're going to do the same. We will remove the support from here and we will assume this vertical force. So the beam will go upward from here, but it will remain connected to this support, so it will be on this shape. As you can see, it will rotate around this hinge. So now let's start drawing the inference line. We will go here, we will draw the same shape here. The value at the support equals 1, and this dimension is 4, and this value is 1. So this means that at 1 feet, the value here will be 0.25, in addition to the 1, of course, 1.25. It is very simple. Here you have 4 feet, and the value here is 1. This is the same slope, so when you add another 1 feet, if 4 feet gives us one value of the inference line, so the 5 feet will give us 1.25. We will do the same here. This will be the shape of the inference line, and here the value equals 1 at the support. So here at the other side, if this is 1 at 4 feet, so at 1 feet this will be minus 0.25. And like we explained in the last slides, you can see that the summation at any point equals 1. Here it is 1, here it is 1, and here it is 1.25 at upward, and here it is minus 0.25, so the summation again equals 1. Let's have another example. Here we have a little more complicated shape, but still you can see that it will be very simple. We have this beam here, we have this moving load, and we want to draw the inference line for the reactions at supports A and B and C. Here we will start drawing the deformed shape, and here we will draw the inference line. So first we will remove the support A, and we will assume a vertical force upward going here. You will see that this beam, it will remain the same. This joint here, it allows the rotation, so the beam will just move upward here, and this part, it will remain connected as it is. At point B, again we will remove the support B, and we will assume upward force. Here it allows rotation, here it allows rotation, so this whole part, it will go upward here, and it starts going down till it reaches 0 at the support A. So this will be the shape of the deformed shape. And finally, at point C, we will remove the support, and we will assume a vertical force going upward here. You will see that this beam, it will move upward. This hinge, it allows rotation, so this part, it will go downward, and it will go upward again till it reaches 0. So this will be the shape of the deformed shape. Let's go here now and start drawing the inference line. Here, this is the value, this is the shape, and the value here at the support equals 1. Here, this is the shape, and the value at the support here equals 1, and this is 4 feet, and this is 2 feet, so the value here will be 1.25. 4 feet has opposite to it 1 value at the inference line, so the 6 feet will have 1.25, and it reaches 0, and here it will be on the same shape. The value here at the support equals 1, and here this space is 2, so here it will be minus 0.25, and it will reaches 0. And again, check, this is very important, just to have a quick look to make sure that you calculated it correctly. Here 1, 0, 0, here 0, 1.25, and minus 0.5, here it is 1 and 0, and here it is 0, 0, and 1. So at any point, the summation of the reactions is 1. Let's have another example. Here we have a cantilever beam, and we have a moving load. We will remove this fixed support, and we will assume a vertical force. We don't have any resistance here. We don't have any hinge or any beam or anything or any kind of support. So the whole beam, it will move upward in this shape here. So the inference line of the reaction, it will be like this, and the value is 1. And this actually makes sense because this is the only vertical support here we have in this system. So wherever you put the moving load, the vertical reaction, it will always be the same. If you have a 4 kilonewton vertical force, it doesn't matter at any point you put it, you will keep having a 4 kilonewton upward force here. It will the only difference will be in the moment, but the vertical force, it will always be the same as the case of the cantilever. So this is it for our video today. See you in our next video. Thank you.